So what do you do when you have one of the biggest engines you can get for a model turbine aircraft? Well, you buy a massive Skymaster 1/5 scale F-16 and you stuff this into this. Ladies and gentlemen, welcome back to the channel and welcome to the Skymaster 1/5 scale F-16 with a monster Swewin 400 engine. Let's take a look at the equipment going in this aircraft. So if you missed the unboxing video, I'll link it down below. Also, I'll link the playlist down below, but the unboxing video was pretty cool, but this is the beginning of the build series. So as per usual, we've got all of our equipment laid out here. Let's take a quick look at what we are installing in this aircraft. So our control system, like normal, is a Jetty DS24. This is my radio. The owner's got basically the same radio. So our control system is going to be a Central Box 320. Now the way this aircraft's going to be powered is we're going to have two 3-cell LiPos powering the control system. The benefits of the 300 series from Jetty is you can have a 3-cell LiPo going in here. You can say, I want every output to be 8.4 volts, and then you're getting the true power of the servos that you pick. So the 320 is our main power hub for this aircraft. We're going to be using the MKS carbon horns in a lot of places on this aircraft. I love these things, they're awesome. And then our servo of choice on every servo is going to be the MKS HBL brushless 599 servos. Great servos, 6mm output shaft, and these are wonderful servos. As per normal, when we're running a Jetty system, we're using a Cortex Pro. Love these things, they integrate so well with Jetty, and we've got all of our Jetty stuff there. We'll take a look at that in a second. We're going to be using Zykoy air valves everywhere, and we have a Zykoy sequencer / failsafe, which is going to provide the failsafe function and the sequencing of the aircraft. Our main receivers are going to be the Jetty Rec 7s with a 40cm dipole antennas. That's kind of our normal for our aircraft. So we've got two of those going in here. We've got an R3, which is an on-off switch to turn everything on and off. M-speed sensor, this will be installed in the aircraft as well. So this M-speed sensor is a pitot tube setup. Now with the Swewin 400, that is our power plant. That's going in this wonderful plane. And we did do an unboxing, test run, a review of the Swewin 400 engine. Unbelievable. We actually ran this particular engine about a week ago, one evening when it showed up, and we got 90, I think it was 90 pounds, 90.25 pounds or something of output. Absolute monster. Now, the Swewin 400 engine uses the black box setup. Because that is primarily a UAV engine, it is not something that is commonly used on our model aircraft. So it's a bit of a different setup here. There's no standard telemetry port or plug or anything. There are obviously very different cable setups. If you haven't watched the review video, I definitely suggest you check it out. Fuel pump is built into here. There's a main board and stuff in here. Now we've gone one step further. We took a Jetty MUI 30 and we installed it in between the fuel pump and we'll call it the ECU, basically the brain that's inside here. This MUI 30 plugs into an EXT port on the Jetty setup, and this gives us a few points of telemetry which are very helpful and will give us exactly what we need for this engine setup. So what does that mean? Well, basically it means that we're going to get two things. Number one, we're going to get voltage, and if the voltage goes to 0, that will signify a flame out because the fuel pump is not working anymore. And we've also got milliamps used. So what we did when we were running this engine is we ran a liter through the engine and kept track of how many milliamps the fuel pump used. So if it was 60 milliamps, we know that 30 milliamps equals 500 milliliters or half a liter. So we've got fuel consumption because we integrated the Jetty MUI 30 unit. Tiny little sensor, it's stuck right over in this part of the black box. We've got the line coming out, all fully integrated and simple. So step number one with any build, two things we do. We burn in our servos, we put them through the servo torture test, the cycler, and we also update all of our Jetty products. So that's going to be the first thing that we do. The owner has sent me a file which we're going to use for our programming purposes. So that's pretty simple. We'll upload that to my radio and we will update all of our Jetty stuff and make sure we're good to go. So I'm going to get that stuff going and I'll check back with you in a minute. So a couple other important things here. This is my black book. This is my master notebook. I'm a little old-fashioned when it comes to that stuff. I keep a notebook like, well, that is my black book, about all my builds, the equipment that goes in them, all that kind of stuff. So that is like my master book. So when I'm organizing a build like this, most of the stuff I like to do electronic, but when it comes to like making notes, I just like it written down on paper. That's the way I am. I don't know if that's a tip or anything, but that's just the way I work. So why am I sharing that with you? Well, I've got some notes here of all the things that we're doing. So we're going to be weathering the gear. We're also going to be painting the gear. Paint. Name on canopy, red on air brakes, chute mechanism. We're going to be adding a chute to this plane. Gear paint and weathering. Oops. Already I wrote that down there. We've got our battery layout here as well too. So other thing we've got coming is a new pipe from JT Joe Tamaz and JT Hobbies, I think is the name of his company. So this is the stock pipe here. So it's 1,005 millimeters long from bell mouth to end of pipe. Inside diameter is 95 millimeters. Outside is 110. So 95 is way too small for a 400. And this is the pipe that we'll be getting. So the inside diameter will go up by 1 inch. So 120 millimeters inside diameter. The outside diameter will go up by just under half an inch to 130 millimeters. Our overall length also gets a little bit longer as well. So we're going from 1,005 to 1,025, so 20 millimeters longer. It just is going to fit better in this plane. And these are my measurements. And then also I've made a note here to add a fuselage former support at 190 millimeters from the tip or the tail part of the pipe. This is the part that actually sits in the former that supports the back of the pipe. So that's why that is written there. So those are some of the changes we're making or the additions that we're doing, the custom things on this aircraft. All right, so spent some time here just getting all of our Jetty stuff programmed, updated, and also went through and did some programming here as well. So one thing to consider when you're using something like a 320 is you want to have your high draw items on 1 to 4 and 18 to 15. So we basically are putting all of our control surfaces on those guys. So if you look at that, we've got ailerons, elevators on our first 4, and then our other one has rudder, nose wheel, slats, and slats. So that's how we've organized stuff. I believe we've got everything, but just going to give some thought to that. So we are painting the landing gear and weathering the landing gear. So because that is happening on this aircraft, that's going to be one of the first things that we take care of. Now, if we weren't doing anything to the landing gear, we would take the landing gear out and Loctite everything. But in this case, we are going to take the landing gear out. It's going to be painted, Loctited, reinstalled, and then we'll weather the landing gear when we weather the rest of the plane. That's the process. So the actual weathering of the entire plane that's happening and the gear, of course, is going to happen at the very end when the plane is done. All right, guys, and it is time for another episode of Tip Time. It's been a while since we've had a Tip Time, and this Tip Time is brought to you by Trusty Bent Screwdriver. At the time of recording this video, there are still some Trusties left available on the website. If you don't know about it, check it out, thelightersideofrc.com. I'm going to show you a very cool tip that Trusty just taught me. So this revolves all around Jetty and how everything works. So I'm going to kind of start from square one here, and we're going to show you the outputs. So essentially, when you set up your kind of basic functions and everything, the functions in the radio have a channel output associated with them. Now this channel output, it can be routed any which way you want. But what we've got here is we've got gyro sense as channel number 10 or function 10. Now generally that would be how we would supply additional power to our cortex. We're going to have our cortex here. We're going to have a receiver going into the cortex. The Cortex is going to be plugged into our receiver port here, and that's how everything's getting powered. Then we would take an additional power lead, just the positive, negative, run it to the Cortex, and that would provide additional power. We need one more channel for this aircraft. Let's see what we can do. We need an afterburner channel. Now we could just Y it off of our throttle channel, which is channel number 9. So just use a Y cable. One lead goes to the turbine, one lead goes to the afterburner. The afterburner only needs signal. So what we do is we create another function. So we've got function, or channel as some people will refer it to, as channel 19. Well, there is no 19 on the Cortex or on the central box, but we can go in and change our output mapping. So we're going to go into Model, Device Explorer, Central Box 320, and we go into Servo Output Mapping. So this is all the outputs on the Central Box 320 and how everything is mapped. So what we've done here is output pin number 10, which used to be our gyrosense channel. We switch that to afterburner light. So what's going to happen with this channel is we're going to have the white wire, or the signal wire, going to our lighting controller to control the afterburners. And our positive and negative wire are going to go to the Cortex and provide additional power. And now we don't have to use a Y lead on our throttle channel, and the world is a happy place. Now, if you didn't follow that stuff, watch it again. If you're a Jetty user, you should be familiar with this stuff, because this is one of the powers of most modern radio systems, but I'll just use Jetty as an example because that's what I use. All right, so we've got all of our electronics and stuff all done, all initially set up. All of our servos have been cycled. It is time to take the gear out of the aircraft. That's going to be a bit of an adventure, but we need to take the gear out to, number 1, paint it, number 2, Loctite it, number 3, reinstall it. So let's get that stuff organized. We're going to take the front of the fuselage back off. This was installed because we got some pictures when we unboxed the aircraft. So let's split the fuselage and get going. All right, so we got the fuselage up on the workbench here. We've taken the front end off, and it's time to pull the tanks out. Now the tanks should come out just because we need access to like these bolts in the front here just to take the entire gear system out. So we'll just pop the engine rails out, and then we'll pop our front tank mounting points out and yank all of these tanks out. Okay, so tanks are out. Fairly straightforward. The front tank has 2 bolts. The back tank, you've got the engine rails holding them in, and there's a fixing point on the underside of the tanks. These saddle tanks are much bigger than I actually thought. I figured they would just be like straight tanks like this, but they're actually very big. I think the fuel capacity on this aircraft is about 8 liters, which is a lot. So that's the tanks removed and what it looks like. There's a couple considerations here. Our fuel fitting at the front is going to be fairly close to this wall, but it's also fairly close to the top. So we'll probably put a bit of a relief cut in here just so our fuel tubing can come straight out and then go where it needs to go. We are going to be reinforcing the intake duct as well. So we're going to put a central piece in, which is a scale piece in the middle of the intake. So it's going to look basically like that. So we'll do that, and then also, like I said, we're going to cover this duct here with carbon fiber. Point of that is, of course, it's pretty flexible, and I'm sure with a 400 Newton engine, we want to make sure the duct is not going to collapse on itself. And that also brings up the point of doing the rest of the intake duct. So we're going to completely wrap this guy in carbon as well. But first step is still getting the landing gear out. All right, so I know people have struggled in the past with this landing gear. Now, you don't need to take the entire I-beam structure out, the entire aluminum structure. You can get the gear out by being creative with this. Now, we are going to go in and we're going to Loctite our I-beam structure. So we may take that out after we get the gear out, but it's going to be easier with the gear removed anyways. So the reason for that is there's some hidden fasteners in here. So you've got this front plate as an example that is bolted. You can see where the fasteners would go in because the material's extended right there. So those aren't going to have Loctite on them now. you know, they're probably tight. It's not, is it super critical? Well, you've got this entire area front to back that's held in place. So we'll take a look at it and see. But basically what you do is you undo this front bolt here, which is this guy right there. Then you can undo this guy right here, which is the actual strut mechanism. And then you can manipulate the actual leg to get at the set screw right there. And you undo the set screw a little bit and your pin comes out. Now the pin, we're also going to add a flat spot on the pin. We're going to do that on every pin in here. So while this is out, I'm going to flat spot those now so they're already done, and then we'll put the pin back in here. Now we're not painting this portion of the gear, right? We're not painting the structure inside. All we care about is this stuff right here. Okay, so getting the front gear out, it's fairly straightforward. It's actually more simple to unbolt it because it's just 4 bolts. Right there and there. So you have to have the gear sort of compressed. You slide it this way in the opening, so that's why this arm needs to be down a little bit, so it'll slide this way. This end comes up and then the gear just pops out. So it's actually pretty simple. What we're going to do as far as painting on this guy goes is we're going to paint from this part of the leg down. I mean, this is basically not visible when you're in line with this. We're not going to do anything with the structure. And then we'll do the same thing here. We'll just paint our probably this leg right here, but we're not going to do any of that structure. So when I take apart gear like this, I like to take lots of reference pictures. So I take them from all angles. You can see I've also marked the tires here. So I've taken a picture of our left assembly from all different angles. So I have those reference pictures, and just taking apart the right side now as well too. So one of the critical things is the brakes. So you want to make sure that you're taking pictures of the brakes and how they're supposed to go on. So I've already taken the pictures, but what I'll generally do is take this shot right there, and then I will take the pieces out one at a time like this and have a picture like that. Generally, the first step I'll do with the landing gear is I'm going to do all the Loctiting beforehand. Now, in the case of the wheels like this, I prefer to spray them together, assembled. You can do either way, works totally fine, but I prefer to do them assembled, prep off the tire nice and tight around the rim, and get it all cleaned up and spray it while it's together. You don't have to do it that way, that's just the way that I prefer to do it. There's lots of nice grease and everything inside these Skymaster wheels, so I like to preserve that as much as possible so it stays sealed, and generally works out quite well. So what I do is I just go through and do all of our Loctiting on all of our fasteners. So basically any screw on the gear, or in this case the tires, wheels, need to be Loctited. So we'll do all those guys, and then we'll go through and do all of the screws on the actual landing gear itself, and we'll also flat spot any of the pins that have a set screw. That's an important step as well. That ensures that the pins don't back out. Okay, so for no other reason than I want to, I'm gonna set this gear aside for right now, and we're gonna focus on getting the aluminum plates and I-beam structure and everything that's gonna be mounted in the fuselage, get this out, Loctited, and put back in. I feel like once I get this done, then I'll have the motivation to move forward and deal with the gear. All right, so pulling the gear out is definitely a bit of a challenge. There's a whole bunch of screws holding this in. Now it doesn't seem like you can get it out. The key here is this wood plate, the spacer plate, is not glued in place. So you slide the spacer plate out, and then everything is nice and loose and easy to take out. All right, so our I-beam structure is out. Now, what's the point of doing this? Well, the point is, see all that? Those all need to be Loctited. Super critical. Those guys there need to be Loctited. Those guys there need to be Loctited. Now the thing is, they're hidden, right? So they are against structure, but if these come loose, the whole thing is going to wiggle and the integrity is going to be compromised. So that's why it is critical to take your stuff out and Loctite it. Loctite it, Loctite it, Loctite it. Okay, so we got our structure back installed. Definitely not an easy thing to do, but it is, as I've mentioned, 100% necessary. So that's back installed. We won't do anything with the airlines until the gear's back in, so that's kind of on pause right now in the fuselage. Next thing I've done here is I sanded out our little tabbies, or our little glue grommets. These are actually, one was loose anyways from the intake. So we're sanding those out. I'm going to sand that one out, and the point of doing that is so we can wrap this intake with carbon fiber. So you can see there it's quite thin and flexible, and we don't want that collapsing at full throttle or while the engine's running. So we're going to wrap this as much as we can access in here with carbon fiber, and our removable duct piece right here is also going to get wrapped in carbon fiber. So I talk often about productivity, and this is a great example right now of what I mean with productivity. So what I'm going to do is we've got a couple things on the go right now. We've got the intake ducting, which we are ready to install carbon fiber onto, and we've also got our landing gear, which is ready to paint. So what I'm going to do is I'm going to work on the landing gear first. We're going to get all that stuff primed, and then what we're going to do is we're going to do the carbon on the ducting, and then we'll come back and paint the landing gear when it's possible to paint it. So just kind of bouncing back and forth, always having a few things on the go, not just focusing on one thing and sitting and waiting for it. That's always my ultimate goal. Doesn't always happen that way, but that's the point. So some of the basic tools when you're prepping gear off like this, obviously, is masking tape. What I use to clean everything up is rubbing alcohol, 99% rubbing alcohol. A toothbrush is very handy because I will spray these down with rubbing alcohol, get into all the nooks and crannies and crevices, and then I'll give it a spray down with brake cleaner and blow it off with a compressor. That just helps get rid of any of the silicone lube or lubricants or anti-sticking agents that happen to be on the parts. Probably the most complicated parts of this all is going to be the main legs. The front wasn't so bad, but it's important to get in there and just make sure you scrub everything down to get good adhesion with your paint. And the other thing we will do, now I've talked about this a fair bit on other gear that I've painted, like the previous F-14, the Hawk, is I will preheat the parts with my heat gun. So it's 20 degrees Celsius in the shop, 70 degrees Fahrenheit, nice temperature, but the primer and the paint will stick way better if you preheat the little items with your heat gun. They don't have to be like cooking hot, just warm to the touch. I found it helps a ton. All right, so there's some of our wheel pieces all primed. So what I'll generally do with this stuff is I will heat up my part with my heat gun right there. And while I'm doing that, I'm also warming up the can of paint as well too. Now, I'm not suggesting you warm up or heat up your cans of paint because that would go against the warning labels on the cans of paint, but I do it. Do it at your own discretion. It works really well. So those parts are done. We're just going to keep plugging away and getting these things primed, and then we'll be putting our finish coat on top. All right, so just a little suggestion here. If you want an indoor paint booth, that works quite well. This is what I do, and I hook it up to my shop vac, and it's pretty amazing. So it really sucks down all the fumes. Obviously, all the fumes and paint dust and everything are going inside the vacuum. There's a bag and a filter inside the vacuum, so all of those paint particles, they're either going to stick to the inside of the hose or they're going inside the filter, inside the bag in the shop vac. So that's my little setup, works well. It is really cold and wintry outside right now, so that's why we do that. And we've got our paint installed on all of our pieces, so it turned out really nice. We need to leave those dry for probably 24 hours. It's going to take a while. So the products we used for this primer, self-etching primer. So the metal has to be cleaned very well, but the self-etching primer is really good. I let this dry for about 2 to 3 hours, and then I use Tremclad oil-based paint. Works very well for this application. Now the oil-based paint, it does take quite a while to dry, and the oil-based paint is a primer and paint in one. It's just a rattle can, but I find it works better if you use the self-etching primer and then go over top of that. So that's the process, and our gear is done. So our wheels are there as well, they're drying, and we've got our wheel parts and brake parts there for the front as well. So we're just going to leave that stuff alone and let it do its thing. We really can't touch it, can't breathe on it, can't move it, can't assemble it until it's dry and cured, obviously. So time to move on to another cool part of this F-16. Okay, so we were initially going to get a smoke tank from Skymaster. The kit didn't come with one, but the Skymaster smoke tank kind of goes right in this area right there. Now, the problem with putting a smoke tank here or putting it anywhere in this front section is your CG is really on this location right there. So if you put something here, you're in front of the CG. If you put it here, you're way in front of the CG. Obviously, the tanks themselves are pretty stinking close to the CG, which is good. So I saw a thread on RC Universe recently, and one of the fellows on there, I don't remember his name, but he made smoke tanks that go right in this area right there, one for each side. It's actually quite a big cavernous area, just like the main tanks here, basically. So we've got tons of room in that area, and we should be able to fit quite a substantial size tank. So we're going to custom make some tanks. So the process we're going to use is I'm going to, number one, get a basic shape down. Number two, I'm going to draw it in Tinkercad. Number three, I'm going to 3D print a very squared off version. And number four, I'm going to send the STL file or CAD file to Joe at RC Custom 3D Printing. Joe's my man who does all my my kind of fun technical projects. He helps out here a lot at the shop. He does all of our 3D printing for us. That's where we get all of our stuff from. So thank you, Joe. And basically, Joe is going to make our tanks for us. Now, he is going to make a plug for the tank. So if you happen to be building one of these and you want smoke tanks for the location that we're doing them in, you know where to get them. So step number one, we need to come up with a shape that fits in that location. Okay, so we're just templating up the tank here. What we did was we took the tank, laid it over some cardboard, just got an oversized basic shape and cut that out. And we installed it in the area where the smoke tank's gonna fit. And basically we came up with just a rough shape that kind of fits generically in the front or the back of the little smoke tank compartment. So now what we need to do is we need to get some measurements off this and make up our basic hand-drawn shape. All right, so we've engaged the help of the Bamboo X1 carbon. So what I did was I did our basic layup here, and this is the shape of the tank that I came up with. So 145 left to right, 150 millimeters long, so front to back measurement, 95 on one side, 40 on the other, so it makes a nice shape that I think is going to fit perfectly in there. I did the calculations online here, and it looks like we're about 1.3, 1.4 liters with sharp corners. So when this gets rounded off, we're probably about 1.2 liters, I would think. And there's a shot there of the basic shape, so that's standing up just for printing, but the short end right there is going to be sitting against the wing on the aircraft. So I think that's going to work perfectly. So we're going to let the machine do its thing. It's supposed to be done in about 3 hours to print that, so we will return and report and make sure that it fits. As soon as we confirm that this is the right shape and we're happy with it and it fits, I'm going to send this file off to Joe. He's going to work on doing all of his stuff, his magic to make these tanks. All right, so the X1 Carbon is making some crazy progress there, printing like an absolute banshee. Going to knock that thing out pretty quick. Time left is 2 hours and 28 minutes. All right, so we're doing things a little bit weird in this build. It kind of happens when I've got some different things to figure out. So in this plane so far, we've painted the gear. We had to take the gear out. That's a different thing than sometimes normal. And we're having to figure out our fuel tank or smoke tank situation. So we're doing kind of random things in this video, which is totally fine. What I'm going to do now is more random stuff. So we're going to work on fuel tanks, and then we're going to work on the intake reinforcing. So that's the next things we're planning on here. Now, just some suggestions for you. When you are doing the tanks in a plane like this, make sure you put them in and confirm where you're putting stuff. So we're not using the stock hardware here. So we're putting an aftermarket bung in, an aftermarket vent fitting. So you want to make sure you don't just guess where this is going, right? So we've taken our main tanks, installed them, and just confirmed that we are okay with that vent fitting. So this vent fitting is going to come forward, and that vent is going to be somewhere in the front part of the aircraft is the plan. We might end up putting it right down in this area, so a taxi tank can just go right on the wing. I think that would be good. Anyways, lots of room in this area on the side for vent fittings and stuff. But we also want to take a look at our front tank, or main tank, right here. So our bung position is fixed, but where are we going to put our vents? Now, if we put our vents up top, it may interfere with our intake ducting. So we're going to take a look at that and see. But ultimately, those vent fittings need to come up to the bung on the saddle tank. So the line, wherever we put it's just going to come forward, come beside the intake here, and then just go up this way. So it's going to be a nice short run, and I think that is going to work just perfectly. Okay, so we've installed our intake duct, and this allows me to get my hand underneath there and feel how much space we have. And we actually have a decent amount of space, so we can put our vent fittings on top of the tank, which is ideal. We can have them on the top of the tank, kind of angled like this, so the tube's going to come straight up and into our bung fitting. Okay, it's tank time. So we are using the DreamWorks high flow setup here. So you can buy the individual parts for this, or you can buy the kit. So we're using 3 kits, which is these guys here, plus the Virilison tubing, which is awesome. This is the same in black as it is in clear. So if you're using the black version, it's identical, it's just black, right? And then we're adding one more high flow vent fitting, which we have in stock. So we're going to have 2 vents here and 1 vent on each of these tanks. Now, if you think about the way this fuel system is going to work, you're going to fill up your UAT. That's going to fill up this front tank. It's going to come out the vents and split and go to the bung fittings on each of the saddle tanks. And then it's going to come out here and go outside the fuselage. So these 2 tanks here, it's very important that everything is identical. So our clunks inside are going to be made exactly the same. And then our lines feeding these vents to this fitting here are going to be exactly the same. So those are important steps. The other nice thing about these DreamWorks ones, they're a smaller size fitting. I like the fact that they come with little holes in them, but they're almost the perfect size to fit in the stock Skymaster holes. So what I do is I take my Dremel and just sand down around this glue joint area here just to create some more bite on the glue. And then we're going to also sand down around the glue spot right there as well. So and then we have to open up the hole just a fraction, not very much at all. All right, and all of our fittings are installed on our tanks. Everything worked out well, and I am happy with all of those fittings. So that's perfect. The other thing is our X1 carbon. Finished printing our tank here, and it turned out awesome. Our vent's going to be right at the top, and we can run our vent line right through that hole right there. But that turned out awesome. The only change I have to make is I made this dimension, front to back, 150, and we're going to make that 145, so 5 millimeters shorter. Reason for that is when we pull this out, it's contacting the engine rail mount, and probably would be okay, but better just to knock 5 millimeters off. I'd rather do it off the tank than the mount right there. So anyways, that's the design. Turned out really nice, happy with it. And okay, so we're getting ready to install our carbon fiber on our intake duct. So we've got this area cleaned out, and we've got the area accessible through the nose door opened up as well. So that's going to give us access to pretty much all the way around the ductwork. And then we've got our duct extension. We need to give this a sand as well because this has a fairly glossy finish to it, and we want to make sure the carbon sticks. So we're going to take our 120 grit sandpaper and just give this a light sanding. Okay, so we've got our West Systems epoxy mixed up here. You can see it's good to go. And then we've got our duct all sanded down, cleaned off. We've got our carbon cut ready to go. So this is really heavy, I think 6 or 7 ounce carbon cloth. We're going to do one layer around the entire duct that will make it incredibly strong. Got our brush, very straightforward, just paint it on, lay it down, make sure it's all stuck in place, let it sit till tomorrow. All right, so it's the next day and our piece is all cured. I didn't show you guys the final result last night, but this is basically it. So I did one big wrap around the entire thing. This is also the visible part, the top part. So looking from inside the fuselage, this is the end that you'll see. We hid all of our ugly joints on the underside. But so we did one big wrap there. I had a little section in the center to fill, so I put a big piece over top, and then I did 2 wraps on the end here. This may get cut back some, but at least we've got a nice strong reinforcement on the turbine end. So this is insanely different. This is so much different than the stock duct. The stock duct, especially on the joint here, you could just take that and fold it in, no problem. And now it is bomb-proof. Well, let's not say bomb-proof because all the keyboard warriors out there will prove me wrong, but it's pretty stinking strong. And our intake duct here, I did a wrap around both sides. So this comes about a little over half around each side. And we did a nice thick layup on epoxy there. I may do a little bit more on this side right here. I'm not sure yet. We're going to see how that all works, but it is also much stronger as well. All right, guys, and it is Saturday today while I'm recording this, and just want to urge you to check out the Lighter Side of RC After Dark. The After Dark channel, it's a live stream here from the shop. It's a completely separate channel. Live stream here from the shop for 2 hours. We generally do it every 2 weeks during the build season. That's what we've been focusing on. And it's pretty cool because you get to, number one, see videos like you're going to see the content tonight that we're working on a couple weeks before it actually airs on these videos. And the other thing is, probably the best thing about it, it's interacting with you guys. So you get the opportunity to ask us questions and interact live if you're on during the live stream. So definitely check it out, Lighter Side of RC After Dark. I love doing it. It's tons of fun. We usually have some fun company here, and it's just a blast for 2 hours. It goes by like that. All right, guys, and that wraps up the first video in the F-16 build series. As far as the fuel tank goes, a little bit of an update for you. So yesterday I sent the 3D file off to Joe at RC Custom 3D Printing. He has already taken that 3D file, rounded the corners, modified it, did the changes that I asked for, and he's already working on the smoke tank. So if you do fly one of these planes and you are interested in this type of smoke tank setup that you're going to see us do, definitely check out his website, reach out to him, rccustom3dprinting.com. And that's everything, guys, for the first video in the F-16 from Skymaster. This has been tons of fun so far. Next video, we're going to focus on putting the gear back together and continuing on with the process. So last thing I'll leave you with is channel membership. If you guys are interested in channel membership, there's some links down below. Basically, channel membership gives you the opportunity to see the videos as soon as I upload them. So I'll generally upload a video, and it's going to sit there for about a week to 2 weeks. The channel members, you guys, thank you so much. You get to see them as soon as I upload them and make them visible to you. And everybody else, like the normal people watching this, non-channel members, they have to wait, or you guys have to wait for the video to go live on YouTube. So if you're interested in channel membership, that's one of the cool perks. Thanks, guys, for watching the video. We'll see you in the next video.